Sohcahtoa Part 1. This is what we're doing today. We are solving triangles when given a side and an angle. What the heck does it mean to solve a triangle? It's merely finding the lengths of the sides of the triangle and the size of the angles of the triangle. Now, can you remember what Sohcahtoa stands for? Of course you can. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse, while tan theta is opposite over adjacent. Can you remember what opposite, hypotenuse, and adjacent means? Those are the three sides of the triangle in relation to theta. Directly opposite theta is the side we call opposite. The hypotenuse of a triangle is super easy to identify because it's always opposite the 90-degree symbol. And so the third one, the third side of that triangle must be the adjacent to theta side. Now, if you look at Sohcahtoa, sine is opposite over hypotenuse. There's a theta involved, and two sides of the triangle are involved in each little formula. So each formula has three parts. If you are given a right-angled triangle with a certain amount of information, you're going to need two of the three parts of each formula in order to solve for that third part. And that's what we are practicing today. Oh, note, that little angle at the top of the triangle will be 90 degrees minus theta because of the angles of the interior angles of the triangle add up to 180 degrees. So let's jump into an example. If we are required to find PQ in this triangle below when given 29,000 as the length of QR and 73,2 degrees as the size of angle R, all we need to do is think Sohcahtoa. Right, let's have a look. First things first, let's look at let's try and identify what we're looking for. We're looking for PQ. What the heck is that in relation to the angle that we've been given? It is directly opposite, isn't it? So let's go and place a tick next to the formulae that have O for opposite. Sine and tan have opposites in their formula. Great. So that means we're not going to use cos because there's no opposite. We are looking for O, so we need to use the formulae that have O in them already. So that's what our ticks on the slide represents at the moment. Now let's go and tick off some options again. Let's consider what have we actually been given. Do you see that 29,000? Yes, you do. It's not the hypotenuse. It's not opposite. So it must be the adjacent side. So let's go and place a second tick next to the trig ratio that has an A. Aha! Tan theta is opposite over adjacent. So we can replace opposite with PQ because that's what we're looking for. And we can replace adjacent with the value we've been given for QR, which is 29,000. Now, all we need to do is make PQ the subject of the formula. How do we undo dividing? By multiplying, of course. So whip out the calculator, insert tan 73,2, close your bracket, and then say times 29,000. And you will get PQ equals 96,052,6 units. It's as easy as that. Look at how what is inside the blue rectangle is all you need to write down on your working out sheet. That is the calculation. But all the thought process around the blue rectangle is really, really important for you to ensure that you write down the correct information. So this triangle is exactly the same as the previous one, but now instead of looking for PQ, we are looking for PR. Before I even dive into that, do you know how to find the third side of a right-angled triangle if you are given two other sides? In other words, we've already worked out PQ. We've already worked out QR. So how are we going to find the length of this hypotenuse? Ta-da-ta-da, it's Pythagoras, of course. But in this example, I'm going to show you how you can use Sohcahtoa once again to find the hypotenuse. Let's follow the same process we used in the previous slide. We are looking for that question mark PR. What is that? Is it opposite, adjacent, or hypotenuse in relation to 73,2 degrees? We can see clearly that it's the hypotenuse, right? So let's go and tick off each trig ratio that has an H for hypotenuse. That will rule out tan. Now, which piece of information have we been given? Well, in case we got PQ wrong in the previous question, let's not use our PQ. Let's re-look at that 29,000 units and see that that is the adjacent side. Now, between sine theta and cos theta, which formula has an A for adjacent? Aha, cos theta. So we are going to use cos theta equals adjacent over hypotenuse, which is 29,000 over PR. I'm now going to take the opportunity to give you a quick tip on how to make PR the subject of the formula. Since the left-hand side of this equation has no fraction and the right-hand side of this equation does have a fraction, we can apply this little triangular method. Always write the top of the fraction in the top of the triangle, and then the other two pieces of information will be in the bottom, at the bottom of the triangle. Now cover the part of the triangle that you are looking for. So we're looking for PR. So we're going to cover the PR, and you'll end up with 29,000 on top of 73,2 degrees. Now you're ready to whip out the calculator and substitute in those values, and you press equal to get 100,335 units as the length of PR. If you would like to double check your answer by doing Pythagoras, go for it. Once again, have a look at how the blue rectangle is all you need to show in your working out. However, everything that surrounds it is what needs to go on inside your brain or on the side of your paper somewhere else. It's really, really useful to write down Sohcahtoa and use this two-tick method to confirm which of the three trig ratios you're going to be using as a formula. Okay, grade 10s, good luck. You're off to do exercise 5.6 on page 116. Please reach out to us if you need any help. Give us some feedback on this video if it's too fast or if it needs more info. We are learning as we go. Thank you and enjoy.